Good morning, guys. And today our topic is lamp, types of lamp, and the nature of light. First of all, we have to know which type of lights are visible range and which are not, and then some units, and then we will go for different type of lights. Uh, in practice, generally for the illumination purpose, we have used so many lamps, just like incandescent lamp, fluorescent lamp, sodium vapor lamp, mercury vapor lamp, and some filament lamp. Filament lamp and incandescent lamp are same, and we have to know about the uh, working principle and the working actually illumination mechanism. How is it working? And then in which purpose we have to use, and then calculation also, and then it will be covered all about the illumination and light purpose. So we know what is the light. Light nothing but the ether wave. Okay, there is in practice there is so many waves are there, just like a radio wave, infrared wave. If but which one is select a sound wave? If, but which one is selected as light? Generally, light is the ether wave. Okay, you can see this is the when this ether wave if penetrate over our eyes and our rod cones cells and the cone cells are activated, then we can visualize this. But the visualized range is that you can see this visualized range is 3 into 10 to the power 10 cm2. So this is the visualized, this is the speed, and if you measure the visualized light range, then it will come the zero point 0.4 micrometer meter to the 0.75 micrometer. Within this, we can see the light. We can see the wave as a light, because this is range can penetrate over when penetrate over our cornea, then our rod cells and cone cells are become activated, and it will sense as a light, and so this is called the visible range of light. But there is the other form of light, just like a laser, UV, IR, but this type of this range lights are not visible to our human eyes. You can see the infrared light is not visible directly by our eye, but if you cover this infrared light by your mobile camera, then you can see there is a bluish type lights are passing. Okay, LEDs glowing with some bluish type light. Okay, so this range is not visible to our human eyes. So there is, just like there is so many terms are there, just like lumens, lux, brightness, etc. Otherwise we can't estimate any area to how could I illuminate this, and how much amount of bulb or fluorescent or any other lamps are required. So we have to know this. So, what about the ether wave? Look, it is a succession of wave, radiant energy, as per the definition, you can say. It is a succession of wave of radiant energy transmitted through the ether as a result of some disturbance. Okay, and then it is, you may call it, this is the ether wave, and it is a visible light wave. And the properties and the behavior of these ether waves depends upon their wavelength. Okay, so wavelength is very less, then out of the range of zero point 0.5 micrometer to 0.75 micrometer, then it is not visible by your human eyes. Okay, say some if you enlighted a road with your infrared light, then it will not be visible, but it is lighted, so this is not accepted. You can use it in sensor purpose, not your visible light purpose. So this is called illumination technology. Okay, and now the ether waves having the wavelength between zero point 0.4 micrometer to 0.75 micrometer produces when they are impinging on the eye, then a sensation and is created, and this is called as a light, and this is called the visible light. And for your information, we can remember that all these waves, means ether waves travel at the speed of 3 into 10 to the power 10 centimeter per second, or you may say 3 into 10 to the power 8 meter per second. Okay, this is the traveling speed, light traveling speed. Okay, or you can say this is the velocity. Okay, unit of the wavelength. Look here, some units are depicted over there. uh, Generally, two units are there. One is micron and another is angstrom. Micron is very little, that is equal to 10 to the power minus 6 meter, and sorry, angstrom is very little, that is less unit than the micron. Micron is generally 10 to the power 6 meter, whereas uh, angstrom is 10 to the power minus 10 meter. Okay, angstrom is very less, 10 to the power minus 10 meter, whereas the micron is 10 to the power minus 6 meter. So somewhere you can found that there is written micron. Just remember, micron means 10 to the power minus 6 and angstrom is 10 to the power minus 10. So angstrom is another small unit than the micron. So angstrom is smaller than the micron. And so we have to define some wave which are visible range, which are x-ray. We have to know this because somewhere you may some questions may be arise. What is the wavelength of x-ray? What is the wavelength of ultraviolet ray? This you have to remember this. Okay, you can see in this chart there is a 10 to the power minus 14 meter. This range of frequency, this range of wavelength length is generally cosmic rays. Okay, and 10 to the power minus 12, it is the X-ray. This is called the hard X-ray, and if we go for 10 to the power minus 10 meter, then we get some X-ray. This is also called the soft X-ray. Okay, and then we can go for the 10 to the power minus 8 meter. In this case, ultraviolet rays are in this range. So this is also not visible range, but after then it is come to the visibility, that is up to the 10 to the power minus 6 meter. It is the visible light range, and then again up to the 10 to the power minus 4. Whenever it crosses the 10 to the power minus 4 or surrounding this, then it becomes the IR ray. Okay, means infrared ray. And infrared ray, first it is introduced as a heat. Okay, uh, if we apply some infrared, and then after some time it will creating a heat. Okay, so light is also an energy, we can prove by this uh, infrared ray. And other is very soft, that is very small, that's why effect is very less. And now 10 to the power minus 2, that is short wave radio wave. Okay, and after 10 to the power minus 2 to 10 to the power plus 2, then 10 to the power 4, 10 to the power 6, up to this range wavelength, this is the long wave radio wave. Okay, but you can see that this is the 10 to the power 10 to the power 4 positive. This is a very high range, but actually the frequency is very high. Look, in the left hand side there is another column. If you find it, that you can see that it's 3 into 10 to the power 6 hertz. So 10 to the power 10 to the power 2, and this long wavelength, if it is flowing in the 3 into 10 to the power 6 hertz, then it will called the long wave radio. Otherwise, if you create a wave in your hand, in your any way, but it will not treated as the radio wave, because it will not flow in such a way. This is the units, and they're the light range. Okay, and the visible spectrum you have seen. Visible spectrum, again we have to remember that at that wavelength is zero point 0.4 micron to 0.75 micron, or it we may call it, this is 4000 angstrom to the 7500 angstrom. Okay, and sometimes it is also denoted as the frequency. So frequency is the you can see that the frequency is the velocity by the wavelength. Wavelength is lambda. So velocity is generally light velocity is visible light is 3 into 10 to the power 8 meter, and lambda is the wavelength in meter. So it will given as the hertz. Okay, and now we are coming to the visible light range. Look, visible light range, when it has some different type of different of wavelength, then it will show some different color. Okay, but if we mingled all this color, then it became a white color. But whenever if we can split this color, split this wavelength in a particular range, then it will show some color. Just like you can say the 4000 angstrom, it is the violet color. matlab above it, it tends to ultraviolet let. But whenever it's come to the range of 4000, actually this is a very small wavelength, and that's why finally we can't differentiate it. This is very tough task, and that's why we can say that in this range we are not specify this, and somewhere you can split this in a higher spectrum analyzer others, and you can see the 4000 here it is written 4000 and not perfectly 4000. Above this 4000 angstrom, it will tends to go ultraviolet, but at the range of 4000, at the range, not perfectly at the range of 4000 angstrom, it is showing the violet range. Okay, and then after violet, it will come 4000 to 500, it is blue, and between the 5000 to 6000 angstrom, it will showing the green color range. Okay, and whenever it is come to the 6000 angstrom, it will completely become yellow. Again, within 6000 to the 7000 range, it will showing the orange color range. Okay, and then again 7000, at least at the 7000 angstrom, it will show the red, and after that it will tends to red is the last color. Then we'll go for the tends to the infrared under the whenever your any rod, any metal are heated, then sometimes we are seeing that a red color is emitting, and this is if the red color is above one sorry 8000 angstrom, then it will actually not visible, but this is the infrared ray. Okay, so red color is up to the 7000, and after 7000 it will showing the infrared, which is not shown by our visible eye. And now this is the color. So if you want to specific some color, then you have to choose this type of specific range. Okay, and then the luminous intensity. So luminous intensity, uh, it is so the luminous intensity of a source of a light is specified by comparing it to that of the standard lamp. So what is the standard lamp? Actually, in USA, Britain, France, and they have standardized a lamp. This is specific lamp by made of this is the candle. That's why the one unit is there. This is the candle. Okay, so if a specific candle will have some illumination, then it is found that that is a standard lamp, and we can compare it with this other lamp. Say, and this is the this specific candle lamp is put or in keeping in the national laboratory of these three countries, France, Britain, and then the USA. Okay, and now this candle is replaced by a carbon filament lamp, because candle sometimes it is not specific, very much specific, but they have some specific rigidity, specific shape. They have perfect they have to choose this. And now if you go for the carbon filament lamp, this is now it is getting a standardized one. Okay, so this standardized lamp is compared with the light of this standardized lamp is compared with the other light. then we can find out this multiplication and is there. Say in your room there is a one lamp is there which is 2 times or 3 times brighter than and brighter than your normal one candle one carbon filament lamp, then you can say this is the 2 carbon filament lamp, power is 2, power is 2. In this way we can compare it as a unit. Now the ordinary 60-watt lamp, now the ordinary 60-watt lamp you can see is used in domestic lighting, is view from the floor. Okay, and underneath it and have a illumination intensity is about 70 candle power, means 70 times of a one candle, and this is standard candle. Okay, 60 watt means it is 70 candle power. This is the luminous intensity. And now this is coming the brightness. What is the brightness? Look, whenever we are watching some TV, watching some uh, any light emitting or light reflecting object, then we are using the words the brightness. Just reduce the brightness, just increase the brightness. Brightness means which will penetrate much in your eye. When a source of light covers an appreciable area, as when it is contained in an opal glass bowl, or when the observer sees only reflected light as in screen, the term brightness is employed. This is the defined as a luminous intensity per unit area. Okay, and the expressed in the candle per cm square, or it may be called that is still. Look, the illumination. The illumination on a surface is governed by the amount of light or the luminous flux as falling on that surface meter. Okay, the illumination on a surface is governed by a amount of light, right, or luminous flux falling on the surface meter. Okay, uh, another name for this unit is the lux. Lex. Lex is the lm per meter square. Okay, -2 meter m to the power -2. So the illumination, now put some important topic is there. You can see this. Now, luminous flux unit is lumen, Lm. Luminous intensity, that is called candela, CD. Luminous illumination, this is lux, or Lm means lumen per meter square. And the luminance unit is the candela per square meter, CD per meter square. Okay. And now come to the point of type of lamp. Look, there is so many type of lamp, but in a visible light range, we are using um uh, technology for illuminating the area, and this technology confined in some bulb form or the lamp form, that is called that is differentiate from each to other, and this is the type. First one is the incandescent lamp. This is generic carbon or tungsten filament lamp, or the electric discharge lamp. This is the gas and vapor availability lamp, and hot and cold cathode lamp, sodium vapor lamp, mercury vapor lamp, and the fluorescent lamp. Okay, actually this type of lamp are generally used in our practice, and we have to know the construction, connection, etc. Then then we can use this in our practice. Okay, so first I am starting, that is incandescent lamp. Look, in this incandescent lamp you have seen in your room, and everywhere you can find this type of lamp. Okay, so it is made of a glass, and within this glass there is a tungsten filament. Tungsten is there, and this filament tungsten is holded by a supported wire, and this filament is uh, provided power by this the lead wire, and this all type of wire is holded in this stand. This is called a stem. Okay, and within this there is some the dammit wire, there is some the exhaust tube. Okay, and this is total glass stem. Stem means it is a stem, means a stand. Okay, just so in a plant you can see this, some stem is there, and sometimes there is a fuse wire. One fuse wire is used. Okay, one fuse wire also used. So now one by one we have to know this. First one is the glass bulb. Then we are using some the gas filling, and this gas filling is sometimes, actually it should be the vacuum, but if it is vacuum, then it can get some other problem, oxidation problem, any other thing. Then we are using some inert gas, maybe nitrogen. Okay, and then we are getting some filling with the tungsten, and this is the tungsten is always it is a alloy, and and this filament is used whenever current is flowing through it. It will illuminated, and it is I2RT. Now we have to provide some power to this filament, that is called lead wire. Okay, and this lead wire is made of nickel, and it is plated nickel plated steel, generally a steel, but the plating is done by the nickel. Okay, and the look, within this there is some supporting wire, and this is the molybdenum wire. Okay, and there is some this supporting wire only mounted on this glass slit, and the normal this lead, it which is providing the power, it is just uh, jointed with the welding with some lead wire, and uh, this is another thing that is called it a dammit wire. Okay, this dammit wire is made of steel also, but it will plated with the copper. So in this portion you can see this is the nickel like wire, and in this portion you can see this is the copper wire. Actually these are made of steel, but this upper portion, lead portion, is plated with this nickel, and the lower person, which is inbuilt in this glass, that is plated with this is plated with the copper. Okay, and then this lead wire is attached with the holder side, and the lower side is called the cap, and within cap it is just welded with the other two terminal, which is connected in the holder. And within this you can find there is something is there. Look, here is the exhaust tube. Actually whenever we put this exhaust tube is also sealed. They all glass things are sealed. Okay, by some cementing material, and this is, here is one hole is there. So wherever we have uh, put it, then it is full of air. Then exhaust, this is exhaust tube, it is used to vacuum. Okay, it is used to vacuum. This is the purpose. And in this way we can found that is the if incandescent lamp is built up. This is the fundamental things of this. And in this case, in here is the fuse body is there. Okay, so sometimes here is some fuse there, it can use to break this circuit. So it is all about the incandescent lamp. Okay, and it is used for our illumination purpose in our practice, but the efficiency of the illumination incandescent lamp is very less. But as it is used very much easy and the cost is as low, that's why all over the world this type of incandescent lamps are used in very much up to the before 2000 and 2010, and it is used. But today it is found that LED lamp is much efficient, much energy efficient. Then we are replacing this LED lamp. But till now it is very much used in practice because cost is very low, and the durability is much high. May a one bulb can run normal condition 1 year to 2 years. Okay, That's why we are using this type of bulb, and not only our country, it is also for our throughout this world, and it can handle so many hazardous as environment. That's why it is somewhere it is mandatory, because and this type of in your industry purpose where much heat and other things are there, then this type of bulb are used, okay, because they are the plastic coated lamp, led lamp. This is not uh, la- this is a very long lasting bulb for the hazardous area industry built, but in this bulb is also there. So this is all about incandescent lamp. And next classes we are also going for the other lamps. And you know the connection is normal line and neutral. It is working on the working on the resistance. Okay, means if current is flowing, then resistance will heat up, and this then whenever it is heat up to the above at the range of 7,000 angstrom, then it will creating heated up whenever the wavelength is creating 7,000 as an angstrom, then it is the visible lamp. It is working as a visible lamp, visible light, and this is the main fundamental things of this lamp. Okay, so guys, if you have any question, you may ask me. Otherwise, now I am going to end this meeting. Okay, thank you.